In this problem, we're given the graph of a function g of x. We're supposed to rewrite the points that you see here, these 5 that are on the graph, as ordered pairs, then as a table of values, and finally using function notation. It's obvious they don't want me to use all the points on the line because there's infinitely many of them, and this would be a very, very long video. So let's just focus on those 5 points. In the first question, in this field, we're supposed to write a list of ordered pairs. When you list a bunch of ordered pairs, you need to use set notation, which uses these curly brackets, which you can find on your keyboard. So I'm going to define these 5 points in a set. So the first thing I'm going to do is hit Shift, find the curly brackets on my keyboard, and put a left one. At the very end of the problem, I'm going to put a right bracket to indicate that all the points are in one giant set called G. So the first point here, I'm going to write that as an ordered pair, and it is a pair of numbers, there's 2 of them, and the order is important, hence the words ordered pairs. The order goes that you put the x coordinate first. In this case, x is -5. I need to move all the way over here to get to this point. So I need to move 5 units in the negative x direction, and then 4 units up in the y direction. So that would be the point -5, 4. But we always put our points in parentheses. So that'll look like this. Now between points, we want to differentiate between them by putting a comma between. The next point on the graph would be found by moving 3 units in the x direction and 2 units in the y direction. So the order would be -3, 2. So I'm going to put left parenthesis, -3, 2, cap off the right parenthesis there, use a comma, left parenthesis. My next point has me going 0 units in the x direction. I don't need to move left or right at all to go from the origin down to the point. So that would be 0 units in the x direction. So notice I'm going to put a 0 here, comma. Now my second coordinate of the ordered pair is the y value. The y value is clearly down here at -1. So the y value is -1. My next point right here, one would need to move from the origin 3 units in the positive x direction and then 4 units in the negative y direction. So that's the point 3, -4. In a similar fashion, your last point would be 6, nope, it looks like 5, -6. 5 units in the x direction, 6 units in the negative y direction. So that's 5, -6. The next 2 problems, you don't need to look at the graph at all. You can just look at the set of ordered pairs. But before I go to the second problem, remember that I need to put a right curly brace here. So that's Shift. It's called a curly bracket, or you can call them in general braces. In the table, since the table is written vertically, that means up and down, the ordered pairs are going to look almost exactly the same except without all the parentheses and commas. Since they decided to put x in the first column and my output g of x in the right column, they've chosen to use the same order as the ordered pairs. However, it turns out that with table of values you can do it either way. It's just a matter of convention that we do it this way. But some people might put g of x on the left and x on the right. Perfectly legal in mathematics. But I want to point out that with point notation that can never be the case. It has a specific order no matter what. It's always x first, then y. Input, comma, output. No one ever changes that. But for this table we have the input first. So I'm going to pick my first point and say, well, the input's -5 here. So I'm going to type -5. In my output column here, g of x, that would be 4. When my input's -5, my output is 4. I'm going to systematically do that for all my points. -3, 2 is going to look like -3 and 2. 0, -1, well, the x value is 0. The output, g of x value, for that particular x value was -1. And then I just follow down in a similar fashion, almost copying the points down by just simply getting rid of the commas and the parentheses. Again, remember that this chart could be actually written a different way, where we put the outputs in the first column and the inputs in the second. That's traditionally not done, but I've seen it in several textbooks in mathematics. The last problem, it asks us to put these ordered pairs in function notation. And in function notation, since the name of the function is g, it'll always be written as g of some input x equals some output y. Now the way that the question is written here, it looks like I need to put my input on the left hand side of the equal sign and my output on the right hand side. So for example, g is the name of the function, the input goes in the parentheses here, and then the output number goes over here. So where I've written the word in right here, I'm going to pick my first point and say, well, here my input was -5. I literally could copy this and paste it and put it right in here. I'm just going to type it. My input is -5, and for this particular ordered pair, -5, 4, the output is 4. It is important to note that unlike ordered pairs, you could actually write this the other way around, although I'm not going to do it because the question asked me to write it as g of x equals y. But you could actually write 4 equals g of -5. And notice that the name of the function is still g, the input is still in the parentheses just to the right of g, and the output is still on the other side of the equal sign. It turns out that both these notations are perfectly correct. So I'm just trying to point out that your input and output, the order in which you write them can change with function notation. You could actually change the way the table is constructed, but you never change the ordered pair notation. The ordered pair is always input, comma, output. So I'm going to erase this one. I just wanted to show you that. The rest is just to do the questions just the way I did this one. It's going to be g of input, and I'm looking at -3, 2 now. So my input is -3, and my output is 2. This would be g of my input 0, gives out an output of -1. The next one would be g of, looking at the input 3, input goes in the parentheses, output goes outside the parentheses, so my output's -4. It's kind of convenient that the input's always inside the parentheses and the output is always outside the parentheses. Helps me remember. And then finally we've got g of, now I'm in the parentheses, so I want to write the input number, which is 5 in the last ordered pair. And then my output is -6. That should do it. I know I've never done this problem before, so I'm kind of curious if I go down and submit this whether I'd get it right or not. So I'm going to real quick submit it and see what MathAS says about this. If I go up, what does it say? It's cut off. It's giving me 0.6 out of 0.6 on each part, and the video's cut off, but it says that I've got full score on this problem. So it looks like I